Hello and welcome to section 2. In this section we're going to look at the basic Android lifecycle and activities and how an Android app actually works. We're then going to look at how we handle resources in Android, so importing drawables and then referencing them. And then we're going to look at how we would go about producing an APK file and signing it, and then getting a Play Store listing ready for the future. In this video we're going to go through the basic Android app lifecycle. So we're going to take a look at how an app starts and finishes and how it goes through its various activities, and then we're going to look at the manifest in further detail and then edit and add to it. When your Android app first starts, the first method that's ever called is the onCreate method. If you go into your main activity, you can see that the onCreate method is defined here. There's only one onCreate method in your app, and it is in the main activity, and that's what defines the main activity. It's then going to call the super onCreate method, and then that will then initialize your content view. Once your app has been created, your app has now started, and as a result has been set to a resumed state. These states are both the visible state to the user. Your resumed state is what your app consistently runs in, but this onPause method can be called in a variety of different ways. For example, when you get a call, your app will pause. If you press the home button, your app will pause. If you, for example, go into split screen mode, your app will pause, because in split screen, which was introduced in Android 7.0, only one of your apps can be active. The other one is in a paused idle state. OnStop is called when your app is either killed manually, or if your app has been in background for such a long time that it then gets stopped, and as a result gets destroyed. That's the basic gist of the Android lifecycle, and how this all works is through activities. You can think of an activity as like a screen. I believe I went through this briefly when we set up our Android app. And so this isn't just the lifecycle for your entire app, but this is the lifecycle for each activity. If I, for example, am in Facebook Messenger, I'm on this resumed activity. If I then go into a chat with my friend John, that activity that had the list of conversations will then go on pause, but my conversation with John will become resumed. And then, when I then back out of my conversation with John, that goes on paused, and the list of conversations then goes on resumed. The main activity also has to be further defined in the Android manifest, which you can find under manifests, Android manifest.xml. In here, we can see our activity.mainActivity. Underneath we then have an intent filter. Now each Android activity works on something called an intent. An intent is basically something that says, hey, let's go. That's probably the best and easiest way I can summarize that. So what this is then saying is, the intent filter for the main activity is that it's a main activity, and this is what's going to launch the app. The manifest is a file that is completely open for you to edit. When you add a new activity, you're going to have to be copy and pasting and adding new activities, essentially, just without this main attribute and this launcher category. Also in the manifest, you'll be adding something called permissions. I'm going to show you how to add an example permission for now. In your Android manifest XML, just outside of this application division, go ahead and type in users, and then the autocomplete will come up. Go on there, hit enter, and it will give you this huge list of permissions that you can then go ahead and access. So for now I'm just going to add android.permission.internet, because that's one we're going to use eventually, and that's one I always forget to use. I always get some sort of HTTP exception, and I'm just like, why does this happen? And that is usually the reason why I forget, is because I forget to add that. And then go ahead and just close that tag, and hey presto, we have permission to access the internet in our app. In the next video we're going to go through adding resources to our Android app and then referencing them programmatically. We're now going to add resources to our Android project. We're going to take a look at drawables in Android and how they're sized respectively, and how we're going to reference our resources in Android programmatically so that we can change our values on the fly. So I've previously talked about the iclauncher.pngs, which is basically your app icon in the launcher. a good tip to remember here is that your Play Store icon and your App Launcher icon are separate things. You can have a different icon for your Play Store listing and a different icon for when your app actually shows up in the Android launcher. But anyways, and there are 5 different versions of these. Again, MDPI, HDPI, XHDPI, XXHDPI, and XXX HDPI. Just to help you out, I've made a little table, and this table has the exact sizes of what your icon should be for each of these. And this should give you a rough idea of how different these sizes actually are. So now, say I wanted to import my own drawable. In an ideal world, I would make 5 different images, all with the ratios that I showed you previously. However, for now, I just have one simple image that I just want to show you just how to access through your Android code, just for example's sake. So I only have one image. So I've got this logo here, 256 by 256 PNG, and I'm literally just going to drag and drop it into, nope, it's not going to go in there. Copy, paste, there we go. Okay. Drag and drop didn't seem to want to work there. And now I have my logo in there. Now what I want to do is, in my activity main, all I want to do is, if I can find it, I just want to display this image. It doesn't really matter where this goes. I'll just drop it there. Give it a bit of time, and it'll ask me what I want to use. This was obviously a lot more difficult back in the Eclipse days, but nowadays Android Studio is very helpful, and it lets you pick a color from color palette, or it will let you pick a drawable. And I'm just going to use my logo there. Fantastic. Can I not shift it? Let's have it there. There we go. Marvelous. And that will scale depending on the type of display I'm using. And if you go ahead and click on this text view and scroll down to the image view tag, you can see that it's automatically referenced this @drawable, this folder, and then the logo 256. Job done there. The question you might now be asking is, well, how do I change these XML values in my code? Is there a way I can go about doing that? Yes, there is. As you can see, we can access these resources with r.layout.activityMain. We can access the resource of our activity main layout. So to access our text view programmatically and then change the text of it, we first have to initialize a text view object. Let's just call this TV. Then set it to a value. TV equals find view by ID. And the ID is r.id. There's our text view. And we can actually change this ID. If we go back into the XML, we can actually change this ID if we go back to the XML and just simply under Android:ID, just change this to TV. That'll give us an error here. Just change that to TV, and it's still giving us an error because we need to cast all of this to a text view, because this method can return anything really, you know, text view, image view, layout, anything. And then we can just simply do TV set text, and we can just access all the text methods from here. TV set text, instead of hello world, we're going to say hello universe, because we're just that great. You can then run this app in the emulator, or on your physical device. And there we have it. It initially launches with hello world, but as soon as the app launches, it changes to our hello universe, and of course it displays the image. In the next video, we're going to look at actually publishing and signing an APK, and then preparing a Play Store listing. We're finally going to learn how to publish our basic Android app. We're going to look at how we would go about creating the APK and then signing it, and then also readying a Play Store listing for upload. So in Android Studio, go ahead and click Build, Generate Signed APK, and we're going to create a brand new key store. So go into Create New, choose a path. I'm just going to create a new folder in the root of my hard drive and call it Android Stuff, because I'm that organized. I'm going to create it there, and the file name is going to be Key Store, because I'm creative. Give it a password. I'm going to call it password because I'm just that secure. Give it an alias, so essentially just give it a name, EVH98. Again, password. Make sure that you do not lose this signing key file, otherwise you won't be able to ever publish your application again. And also be sure to use a strong password so that other people can't post applications under your package name. How long this key is going to be valid for? I believe 24, I believe 20... Oh no, I don't think there is a max. I'm just going to keep it at 25, just in case. I believe this is all optional, but go ahead. Yeah, I'll leave it there since it is all optional. Hit OK. There we go. Remember the passwords. I'm confident no one will hack into my computer. Next, set up a master password. Again, I'm just going to go with password. Or, yeah, I don't think there's any need for master password protection. I'm just going to leave it. For build type, if you are just exporting this APK just to simply install onto a friend's device or your own device, then go with debug. But if you're uploading to Play Store, then go ahead and click release, which is what we're going to do now. Finish. And then you can show an Explorer. And there it is. So in your web browser, go ahead and head on over to play.google.com/apps/publish, and that'll take you to the Google Play Developer Console. If that URL isn't valid, then just simply go ahead and do a Google search for the Google Play Developer Console. Pay the $25 developer fee if you haven't already, and then go ahead and add new application. And we're going to call this Best App Ever. Upload the APK. Upload first APK to production. And I'm just going to drag and drop this app release.apk into there. It's going to process it and check for any errors or anything like that. And then there you go. And we get an immediate summary of our supported devices, exclusive devices. We've made it pretty broad. And then you can go ahead and create your store listing here. Go through the content rating checks. Go through pricing distributions and all that, and once you're ready, you can publish your app. You can also see why you can't publish, and Google will give you all list of reasons. Hello and welcome to section Let's Get Rendering. In this section, we're going to take a look at the game loop, what it is, and how we're going to use it with our surface view. Then we're going to use the surface view to render shapes. And then we're going to have a look at events like touch and how our game is going to react to those events. In this video, we're finally going to use the Android SDK to start the actual game development of our game. We're going to take a look at the surface view and to set that as a basis for our renderer and how the system clock works and ticks. So first things first, we're going to want to make our game full screen without an action bar, without the status bar showing, without the navigation bar showing as well, like our normal Android app is. So how we go about doing this is after the app is created, so after the onCreate method is called, but before we set the content view, we want to disable the action bar by request window feature window.feature no title semicolon, and then we can make the game full screen with get window.setFlags window manager go layout params dot flag full screen, comma, copy and paste this. Just gonna do it on a new line just so everything's all, in one place. Our content view isn't gonna be set to this XML layout. We're gonna create a brand new surface view, as I mentioned earlier, and use that to render our game. So here I'm gonna type in new game and pass in this activity. Of course, game doesn't exist. So we're going to go under app, Java, our package, and create a brand new class. And of course we're going to call this game. As I said, this game is going to be a surface view. Game extends surface view. And it also implements surface holder.callback. Okay. We're going to get an error here, so we can just click on that, hold Alt and hit Enter, and that'll give us a prompt to import that class. Okay, and of course we need a constructor, so public game, and we're going to give it a parameter of context. Alt enter to import that, and we're just going to call the super method here context. But we're still going to get errors here because there are unimplemented methods, and we're going to go ahead and override and implement those methods right now. So the first one is override public void surface created, surface holder. The second one is public void surface changed. Now this one's got a lot of parameters, so bear with me. Surface holder, an integer for format, another integer width, and another integer height. And last but not least, public void surface destroyed. And that just takes in a surface holder. So now we have all that. We need a thread for the game loop. It's probably best that we do this in another class. So new Java class, and we're going to name this game thread. So this is going to extend thread. Just the typical Java thread. And what a game loop actually is the concept of the game running through this loop once every frame. And you have a set amount of methods that run per frame. So in our case, we're going to have the game is going to call a render method and an update method, and they're going to be called once per frame. Our game is going to have 30 frames per second, so our game loop is going to be running at 30 ticks per second. So each time the game loop runs, I'm going to be referring to that as a tick. So this game loop is going to be creating this game thread, and then that's going to be called from the game, which is our actual surface, which is our rendering surface, and that's going to be within this main activity. Hopefully that's not too confusing. So in this thread, we're just going to define a few things. We're going to define frames per second cap, which in this case is going to be 30. We need to keep account of our average FPS, just so we can print that to the console, just to see what FPS we're getting. We're going to also need a surface holder. We need an instance of our game here. We need a boolean to keep track of whether or not the game is actually running. So if this gets destroyed, then obviously the game is no longer running. And we also need a canvas to actually draw on. And import that. So let's create the constructor, public game thread. This is going to take the surface holder and the game instances. I'm going to rename that as well. I don't want it to be that ambiguous. We're just going to call the super method and then set the surface holder that we pass in and the game instance that we also pass in to this thread. You should be familiar with the thread class in Java, and as we know, the thread has the run method, so we're going to override that run method, public void run. And in here we're going to initialize a lot more variables, and just bear with me, this is going to get a bit confusing. This is why a lot of people tend to go for other game engines that sort this stuff out for us, but it's good to know where everything comes from. And long target time. So just initialize these variables. And I'm going to go through them as we start using them, rather than go through what each thing is once we've initialized. So just initialize these variables as I've set them out. And let's go through the actual game loop. While the game is running, the start time is going to be equal to whatever the system time is in nanoseconds. We're going to initialize our canvas. And then we're going to try and lock the canvas. This dot surface holder dot lock canvas synchronized surface holder. If that's a success, then this is the important part. From the game class, we're going to call the update method, which we haven't made yet, but we we will go back and do that. In fact, we may as well do it now. So go back into game, and then let's just make public void update. So anything that you want to run with per tick that isn't a draw method, then that would go and update. So, for example, updating someone's health. You know, that is something you'd want to update, but it isn't something you are rendering. So that's one thing we want called, and the second thing we want called is our game.draw, and that is essentially our render method. So these two, well, anything within this container is our game loop essentially. So because we're trying this, obviously we need to catch a potential exception. And finally, if the canvas is not null, we're going to unlock the canvas. But again, we need to try this. We need to catch this exception. So I realize that a lot of this is quite overwhelming and complicated. We haven't really got to the complicated stuff yet, but the block of code you need to focus on really here is this. This is the game loop. All this is just Android canvas stuff that is a bit tedious, but here is the game loop. Anything you want to update per tick, this is where you would. Now we can carry on with actually setting up this whole tick system. So time millis equals system.nanotime, which is the time after all this has happened. So we grab the start time, then we're going to grab the time again after all this has occurred, and we're going to subtract it from our start time. And we're going to divide this by 1 million, and this is then going to get the time after all this in milliseconds. Remember, we grabbed the time in nanoseconds. We're then going to divide it by a million to then get it in milliseconds. We're then going to specify a wait time. So how long are we going to wait until we should draw again? Because there's no point drawing unnecessary frames, are there? So we're going to grab our target time, which is 1000 over our FPS. We're going to grab our target time and subtract that by this time that we've just taken here. We're then going to execute this wait. So this.sleep for the time we need to wait, and then catch this exception here. And then this isn't necessary for the game loop, but this I just want to show you, and that's to calculate the average FPS. So how we would do this, we would grab the total time and add the system time at this point minus the start time, increase the frame count by 1, and then as soon as the frame count then reaches that FPS, we're then going to calculate the average FPS, which is 100 divided by the total time divided by the frame count, and all of that divided by, once again, 1 million, so that we can have it in milliseconds. Then we're going to reset the frame counter, reset the total time, and finally print out our average FPS. Before we go back into that game class, we want to make one final method, and that's public void set running, just so that we can change the value of this running boolean outside of the game thread. So set running to boolean, just so we can start the game and kill the game. Running equal is running. Hop back into our game class, and we're gonna now initialize that thread. So private game thread, and then give it a value. Before we do that, we're going to get holder add callback. This is just so that the callback is set to the surface view, so that we can have events triggered from here. And after that, we're going to make our thread equal to new game thread, get holder, and then pass this game in. We're then going to make this surface view the focused view. And as soon as the surface is created, we're going to thread.setRunning to true, and then we're going to start the thread. Once surface is destroyed, we're going to first create a boolean called retry, because it can take a few times to actually attempt to kill the thread when the surface is destroyed. So while retry is true, go ahead and set the thread to false. Thread.join. Catch that exception as an interrupted exception. And print. And once that's accomplished, then we don't need to retry it. So, to recap, if we go into the main activity, the app gets created, everything is then set to full screen, and the content view is set to this game, which is provided the context of the main activity. The game starts, everything is initialized, including this thread. Once everything's initialized, then that surface has been created. And as soon as the surface has been created, the thread then gets ran. The thread starts to run, and because running is set to true, this game loop is going to kick off, and there this game.update and this game.draw canvas is going to update 30 times every second. So if we go ahead and run this, and as you can see, our game is outputting at 29 FPS consistently. Good enough. Just a slight amendment before we run the game, this is meant to be 1000, not 100. In the next video, we're going to look at how to actually render shapes and colors. In this video, we're going to look at how we're going to render in our surface view. We'll look at how we're going to declare shapes and then color those shapes using the paint class. So before we actually dive into the rendering, I want to focus on this block of code just for a second. Now, this is the block of code that enables our game to go full screen. However, this is how it was done pre-Android 4.4, so before KitKat. Since then, Google have recommended this is the best way to go full screen, or as they like to call it, immersive mode. So again, it's just get window, and instead this time it's, instead of set flags, it's get decor view, so get decoration view, set system UI visibility. And there's a lot of these, so I'm going to do each one on a new line. First one is view.system UI flag layout stable there. Next one, not a comma, it's a pipe. And then we will actually, I'm going to have this on a new line. That's what it seems to be hinting at what it wants. View.system UI flag layout hide navigation. View.system UI flag layout full screen. View.system UI flag hide navigation. View.system UI flag full screen. And finally, view.system UI flag immersive. And there we go, we finally have that sorted. Now we're going to render a player. So what I'm going to do is, in the Java folder, and right here, I'm going to create a new class, new Java class, and I'm going to call this player. Now, the player is going to have a rectangle as its bounds, so that's the shape it has. Just Alt-Enter to import that. And it's also going to have a paint. So we want to be able to actually paint this rectangle. And we're going to have an initializer, player rect, but instead of a paint, we're just going to pass through a color, and colors are stored as integers in Android, or rather in the Android SDK. And so as a result, we're then going to set this rect equal to the rect that's passed in, and we're going to set paint equal to a new paint, so initialize that paint, and then set the color of that paint to the color that we pass in. So that's our player initialized. So go ahead and create a draw method for this player, and in here we're going to canvas.drawRect with our rectangle and our paint. Hop into your game class, and here we're going to initialize an instance of our player. I'm going to do this above set focusable, so player equals new player, and this takes in a rectangle, so new rect, and how this works is we're going to put in our starting coordinates, so I'm going to start, doesn't really matter there, 256, 256, and I want to end it at 384, 384, giving me a 128 by 128 rectangle. And we're just going to pass it through a color of blue. Scrolling down, you'll notice we don't actually have a draw method. So at override, public void draw. Oh, that needs a canvas. And we're just going to call player.draw and pass through that canvas. And we should be good to go to test the app. And there you see we have our little blue player on our screen. In the next video, we're going to look at how we're going to register events in our Android game. In this video, we're going to have a look at registering motion events in our Android game. So we're first going to register whether or not a user has actually touched the screen, and if they do touch and move around on the screen, we're going to transform our shape. So in our player class, we're going to want to add an update method now, along with our draw method. And instead of having no parameters, we're going to pass through a parameter called point. This is because rectangles are weird and how they're drawn, as we learned earlier. Basically how it is you give an X and Y for the top left corner, and then you give an X and Y for the bottom right corner. That's ideally not how we'd like to do it. We'd rather just pass in an X and Y from the top corner and just go, rather than giving two sets of X and Ys. So this update method we're going to make, that's going to essentially grab the values that we're going to give from a point, and a point is just an X and a Y value. That's going to grab the values from there and then adjust it to this weird rect format. So, it sounds a bit complicated, but it needs to be done. So rect set, and firstly we're going to grab the X of the point and subtract it from half of the width, and then we're going to get the Y and subtract it from the half the height, and that gets us our top left sorted. Now we need to sort out our bottom right, so you can copy and paste all of that and simply exchange these pluses, exchange these minuses for pluses. Now we actually need a point, so if we go back into the game class, right underneath the player, go ahead and create a player point. Initialize that right underneath the player, equals new point. Now, instead of this, we can just simply put 0, 0, 1 to 8. This is essentially saying start from the very start of the screen, the top left of the screen, and end at 1 to 8, 1 to 8. Essentially saying I want this to be 128 by 128 in terms of size. Then, in this point, we can then say where on the screen we want it, rather than doing both in this rect, because defining a position and a size all in one is a bit confusing and a bit annoying, really. So here I'm going to, I don't know, I'm going to give it an X of 256 and a Y of 960, because why not? Okay, we need to call this update method, of course. So player.update with that player point. And finally, all we need to do is just register the touch event. So go ahead and add this method. Override public boolean on touch event, and we're going to pass in a parameter of motion event, and this is always going to return true, because we always want to be checking for a touch event. And in here we're going to add an if block, event.getAction, so get that touch event that may or may not have happened, and we want to see if it's a certain type of motion event. And you see, if we go into this motion event class, there's a lot of them. There's a plethora of motion events to choose from. We just simply want move. So if the user has put their finger down the screen and is moving around, if that's the case, we want this player point set to, and as you can see, we're now using X and Y. So the X position of the event and the Y position of the event. However, I don't want the Y position to move. I only want the player to be able to move left and right. So I'm going to keep that constantly at 960. I'm going to paste that in. And again, we still have an error because this is a float, but the method wants an integer, so we're just going to simply cast it. Now, I'm going to run the app now, however, it is going to have one glaring issue, and I do want you guys to see this before we actually fix it. Now, if you have a look, again, we have our blue rectangle just in a different spot. If I start to move it, it doesn't look like it's moving, it all looks like I'm stretching it out. That's not what's happening. It is moving, however, it's just drawing over the previous image over and over again. All this black isn't actually black, it's all transparent. So this is just simply rendering on top of one another. We're not actually clearing the background and regenerating it over and over. And that's something we should do. So it's just a simple one line of code right above this play.draw, and before anything else is ever drawn, we want to set the color of the canvas to... we want to draw a color onto the canvas. And we can go with the black, or we can choose whatever we like. So I'm going to go with white now, just for a bit of change. And if I then run the app again, you can see first of all we have our nice white background, but also if I'm moving this around, it moves as you would expect it to. Welcome to section Enhancing the Game. In this section we're going to take a look at the scene system and how we go about creating our own, using animations in Android, and then using the accelerometer in our game. In this video we're going to go over scenes in our Android game. We'll be looking at creating an abstract scene management system and then creating different scenes for the main menu and the game. We're first going to create a scene interface, so go ahead and create a new Java class, but it's going to be of type interface because all we want to do is just create a set of methods that the scene is going to implement. And so these methods are going to be public void draw, and public void update, just as we've been doing so far, and also a public void terminate, a method that will run when we close our scene and move on to a new one. We also want our public void receive touch, and that's going to take in a motion event. From this we can then create a brand new scene. So we're going to create our gameplay scene. Okay, and it's going to implement that scene interface that we made. Now the reason we are splitting up our game into scenes is so that our code's not all in one class. So I can have the main menu as a separate screen, I can have this gameplay as a separate screen, I can have the help menu as a separate screen, and so forth. And it also reduces redundancies. Things like if I go into the game class here, so things like all this block of code and all this block of code, things like that, they now become redundant. Things like that don't have to be written twice over. They can all be written here, and we can just focus on the actual game logic and rendering in our scenes here. So just carry on overriding these implemented methods. Once we've done that, we can actually copy and paste this gameplay scene and rename it main menu scene. And now we have the template for our main menu scene here. We now need to create a scene manager, something that's going to handle all these scenes together. And we're just going to create a new class called scene manager. And the scene manager is going to have an array list, which will essentially be a list of all our active scenes. And it's also going to have an integer, which is going to act as the active scene. So this integer will keep track of what actually is our active scene that we are going to display to the screen and update. And then we can create a constructor, scene manager, and once the scene manager is initialized, we just want to make sure that the active scene is the first scene. So set active scene to 0. We then can add our scenes, so scenes scenes.add, and we can add our main menu scene, which becomes scene 0 because it was added first, and then we can add our gameplay scene. Now we need to add our overhead methods because we want this scene manager to render the current scene. Scenes.get active scene.draw, to grab whatever the active scene is and run its draw method. And we need to do the same for the update method. Again, same thing here really, we can just copy and paste and just change this to update. And we can do the same for receive touch. Now we have our scene manager set up. Now what we can actually start to do is, from our game class, we can start moving over things that should now be in our gameplay scene. So in our gameplay scene, we should actually create a constructor, public gameplay scene. And we're going to cut and paste this section because these things need to be relevant for all scenes. However, these lines of code are only relevant to the gameplay scene. Import all the following. It's going to give us an error because we don't actually have that player and player point. So we can cut and paste that. What else? This motion event. We can grab this method that is relevant to our receive touch because that's only relevant to the gameplay scene. And we can keep this return true here. The player draw is only relevant for the gameplay scene. And of course the player update as well. Now I'm just going to copy and paste this into our main menu scene. I'm just going to have it, if we touch the main menu scene, then just change it to this gameplay scene. How we're going to go about that is, when the main menu scene is just touched, we're going to run this terminate method. And terminate, what that's going to do is it's going to go into scene manager, and it's going to get the active scene and set it to 1. Because our main menu scene is 0 and our gameplay scene is 1, and we want to now set it to the gameplay scene. Now in our game, we need to actually add this scene manager in there. Because at this moment in time, scene manager is just sitting there and not actually doing anything. Manager equals new scene manager. We now need to reference all these scene manager methods in the actual rendering panel. So we're going to go down here, and here we're going to call manager.receiveTouch and pass in that motion event. In the draw, after we've reset the canvas to white, we then want to manager.draw. And in the update method, we just want a manager.update. And the manager itself will then handle what the active scene is and then run the method for that relevant scene. Now, as you can see here, we have our blank main menu screen. If I then touch here, there we go, we are now presented with our game screen. In the next video, we're going to be looking at animating our player. In this video, we're going to look at using bitmaps and animating them to animate our player. We'll look at how we are going to render these bitmaps in Android and then create an animation engine to stitch them all together. First things first, we want to create a static instance of our current context, and this is so that we can access the resources that we're going to be using for our animation. So go ahead, in the game class, write public static context current context. And then we're going to make this current context equal to the context that we pass in up here. We're now going to go ahead and create an animation class. The animation class is going to contain an array of bitmaps, and that is essentially going to be the frames. Import that. We're going to keep a tab on the index of the frame that we're on, so our current frame. We're going to keep count of how long each frame is going to last for. I'm going to keep account of the last frame and whether or not this animation is playing. In our constructor, we're going to pass in these frames and how long the animation is going to run for in total. I'm going to set this frames equal to the frames that we pass in. The frame index is obviously going to start at 0. The frame time is going to be the overall time divided by the amount of frames that we actually have. And the time of the last frame is going to be the current time in milliseconds. For our animations draw method, we're going to pass through a canvas, of course. We're also going to pass through a rect, and this is going to be the destination of where our animation is going to be rendered. Because how a bitmap works when it's being rendered is, okay, it asks for an image, and it takes that image, but then it wants to know where exactly it wants to draw it, and as a result we pass through a rectangle to show it where. So first we're going to check if the animation is playing. If it isn't playing, then we're just going to return nothing. If the animation is playing, then on the canvas we're going to draw a bitmap. That's going to be frames, frame index, whatever the current frame is. Next parameter is null. Then we're going to pass in through our destination and then a paint. We're then going to write an update method, in which again we're going to make the same check. If the animation is not playing, then just return. If the animation is playing, then we are going to check if the current time in milliseconds minus the last frame is more than whatever the frame time should be in milliseconds. We're going to pass it in as seconds. So basically it's going to check whether or not the current frame has finished. If that is the case, then we are going to go forward to the next frame and we're going to increment the frame index to do that. We're then going to check if the frame index has surpassed the frame's length, so has the animation cycle completed. If so, we're going to reset the frame index back to 0. And then we're going to set the last frame once again equal to the current time in milliseconds. We then need play and stop methods, so public void play. Frame index is going to start off at 0 when we play it, and again we're going to set the last frame equal to the current time, and simply is playing is going to be true. And then for the stop method, we're just going to simply set playing to false, because everything else gets reset in the play method. And then, because isPlaying is a private attribute, we're going to create a public boolean isPlaying method so that we can access the value outside of this class. Now, just like we did with the scene manager, we're now going to create an animation manager. The animation manager is going to create an array of these animations and also an animation index, which is going to be the current animation. In the constructor, we're going to pass through all of our animations. Set the animations to the animations we pass in, and then set the animation index to 0. Then need a method to play the animation, and we need to specify which animation we're going to play. We're going to loop through all of our animations and if we find the correct animation, and if it's not already playing, then we're going to want to play the following animation. Otherwise, we want to stop the animation. because we don't want two animations running at once. And then after all that is said and done, we can set the animation index to whatever the index we pass through in. And a rect. And then we're going to check if the animation is actually playing. If so, then we can go ahead and draw the animation. We can pretty much copy and paste this for the update method and just rename this to update, clear these parameters, clear these, and change that to update. We're finally done with all our background animation stuff, and we can now go ahead and implement this animation into our player. So go ahead and create two animations. So we've got private animation idle, and we're going to have another one called walk, and it's going to have an animation manager. In the constructor, go ahead and create a bitmap factory, which is essentially going to create our bitmaps. And we're going to take in our bitmap image idle that we have here. And we're going to take our current instance that we made in our game class and then get the resources. And it's going to be located r.drawable dot whatever the file name is, so idle. And then this process is repeated for the other images. We can now go ahead and create our idle animation. And because it's not really an animation, we're just going to pass in a singular image, which is our image idle. And once again, it's not really an animation, so it doesn't matter what time we set it, so I'm just going to set it to 1. We then need our walk animation, and this is going to take in two images. It's going to take walk 1 and walk 2. And I guess half a second would be okay for the total animation, 0.25 seconds each for each of them. And then we need our animation manager to actually take in these animations. So a new animation array, and it's going to contain idle and walk. In our draw method, because we're no longer actually drawing this rectangle, but instead we're drawing our bitmaps, we can do animation manager.draw, canvas, and rect. Now here, first we need to implement some code that will make sure that our player knows whether or not we're actually walking or idle. So we can measure the initial position by just taking the left of the rectangle. Further down we can set a state as 0, and 0 would be our idle state, and it would also have our index animation of 0. And as you can see, 0 would be our idle, and then 1 would be our walk. So 0 if that position hasn't changed. If it has by a considerable amount, so if rect.left minus initial position, so if the change in position is more than 5, so that's for the right, and this is for the left. If that position is changed, then change the state to 1. And then in our animation manager, we can play the animation depending on whatever state it is. And then we can also update our animation. Go ahead and play this. As you can see, my player now is idle, but if I move it around quick enough, then it is then animating. And the reason for this stutter is actually because of the screen recording. In the next video, we'll look at how to use the accelerometer with our Android game. In this video, we're going to take a look at sensors. More specifically, we're going to look at how we can use the accelerometer to control our player's movement. So first of all, we actually need to prevent our game from auto-rotating. So in the Android manifest XML, go ahead here where it says activity Android name main activity, just before this symbol here, go ahead and press enter. And then you want to type Android : screen orientation portrait, and this will lock our game to portrait. Once we've done that, we can then create a new class and call this sensor data, and this is where we're going to track the accelerometer in our game. The sensor data class is going to implement the Android interface sensor event listener, and in this class we're going to create an instance of a sensor manager. We're also going to create a sensor and a float array to track our accelerometer values, since the accelerometer will give one float for the X, one float for the Y, and one float for the Z. So that's 3 floats which will go into this array. The constructor is going to set the manager equal to game.currentContext .getSystemService context.sensorService. Essentially, get the sensor manager, and we need to cast this to sensor manager. The sensor is then going to equal the manager.getDefaultSensor, and the sensor type is going to be the accelerometer. So this essentially tells the sensor manager, we want to grab the accelerometer from your long list of sensors. And then the manager is then going to register a listener, and that's going to be this class and the sensor, and then we want to tell it how much delay we're going to, or how frequently I should say, the sensor should update. So we want sensor delay game, because if we were going to have sensor delay normal or sensor delay UI, it wouldn't update that frequently, whereas in a game we need it to be updating quite constantly. This interface implements the methods public void on accuracy changed, which we actually won't be using, but we have to add it anyways. And the one we'll actually be using is public void on sensor changed. And that's going to take in a sensor event. We're just going to make the accelerometer, so this float array here, we're going to make that equal to whatever the values of that event are. And we also want to be able to grab this private float, so we're then going to create a public get accelerometer method, and that's just going to simply return that array. We can then open up our gameplay scene, in which we can create an instance of this sensor data class, and simply set sensor data equal to new sensor data. And in our update method, just before this player.update, what we're going to do is, when the phone tilts left and right, we're just going to update our player's X position with that. But also have touch as an option as well. So just before this player.update, we're going to add if the accelerometer isn't null, then go ahead and player point.set. Again, we're going to have the Y the same, but the X is going to be cast to an int, because we're going to get a float from this. Sensor data dot get accelerometer, and remember it's an array and we need X. X is at index 0, Y is at index 1, and Z is at index 2. Now since this requires a physical device to test, I can't actually show you this running.